All right, so our next chapter is all about radicals, simplifying radicals, solving radical equations, everything with radicals. So our first section starts with refreshing what a radical is and how to simplify a radical and all of that stuff. And we're going to not only do just like square root radicals, but we are also going to get into like cube roots and fourth roots and so on. And so there are three main parts of a radical. And what a radical is, so if we have the nth root of a real number, a, it could be written as the radical expression n radical of a. So what that means, so n is our index. That tells us what root we are taking. So if it's 3, it's the cube root. If that number is a 4, it's the fourth root, and so on. What everyone calls the square root sign, its technical name is the radical sign, because it doesn't just represent square roots, it represents finding the root of anything. So it's the radical. And no, I don't know why it's called radical. It's just what it's always been called. And then the number underneath the radical sign is called the radicand, right? So we have the index, which tells us the root, the radical sign, and then the radicand. Okay. If there is no index immediately written, it is assumed that it's 2 or that it's the square root. Okay, so if there isn't a number here, assume it is 2. All right, so let's do some simplifying of some radicals, which we've done off and on this year. Okay. So the square root of 16, we know this, it's plus or minus 4. And remember, you need the positive and the minus because negative 4 squared is also 16. So for 2, we have the square root of 121, which is plus or minus 11. And then the square root of 4 25ths is plus or minus 2 fifths. Okay, so these are the easy ones. Those are the ones that have whole number square roots. We're good to go. All right, now we are talking about cube roots. So we're finding the number when you multiply 3 of them together, it equals the radicand. So in this case, the cube root of 8 is 2 because 2 times 2 times 2 equals 8. So this answer is 2. All right, so now we have the cube root of 343. You can type this into a calculator or into Desmos to figure it out, or you can Google like perfect cubes and figure out what the cube root is. In this case, it is 7. So the cube root of 343 is 7. All right, so number 6, we have the cube root of negative 125. We can do cube roots of negative numbers because if you do negative 5 times negative 5 times negative 5, you get that negative 125. So the cube root of a negative number will be a negative answer, and in this case, it is negative 5. All right, so cube roots of negative numbers will have a negative answer. Let's move on to the next set. So we have the fourth roots now that we're talking about. So the fourth root of 1, it's not a trick question, it's just 1. And since this is an even index, we're going to have plus or minus again. So the fourth root of 1 is still positive and negative 1. All right, so for number 8, we have the fourth root of 2,401. So it's going to be plus or minus again. We just have to figure out what the fourth root is. So the fourth root of 2,401 is 7. And once again, you can Google this, you can type it into Desmos. There is a way to do it on your calculators. So that answer is plus or minus 7. All right, so for number 9, we have the fourth root of 81 over 16. So we have to find the number that when you multiply it 3 times together, you get 81, and 3 times together, or 4 times together, you get 16. In this case, 3 to the 4th power is 81, so it's 3 over. And then 2 to the 4th power is 16, so it's 3 over 2. All right. So you have this chart here, and it tells us the different possible answers that you could have. So if our index is even, and the radicand, which is the number underneath the radical sign, is positive, then we'll have real roots, which means they'll be real numbers that won't involve I, and it'll have 2 roots, and it will have a positive and a negative. Now, if our index is odd and the radicand is positive, then it will have real roots, so we won't have an I involved. And in this case, if it's an odd index, a positive radicand, then it'll have 1 root, and that root will be positive. But if we have an odd index and a negative radicand, then we'll have a real root, and it will once again be 1, but this time it will be negative. So your answer will be negative. Okay. Now, there's a special case where if you have an even index and the radicand is negative, your type of root this time will be imaginary. And this is where we'll have I involved in our answer. Okay. And this time we'll still have 2 roots and we'll have a plus or minus. But remember, we'll also have the I involved. Okay. So now we're going to start simplifying some radicals that aren't perfect squares or perfect cubes. And eventually we'll get to where we have some variables involved. So what we need to do are we need the factors of 117. So easiest way, Google them or just type them in your calculator. All right. So factors of 117 are 1 and 117, 3 and 39, 9 and 13, and that's it. Those are the only 3 pairs of factors of 117. And remember, we need to pick the pair where one of them has a square root, and in this case, it's only 9 and 13. So this becomes the square root of 9 times the square root of 13. So the square root of 9 is 3. So you have plus or minus 3 square root of 13. And that's our final answer for this one. All right, so then we'll move on to the next one. So we have 4 times the square root of 320. All right, I'm not going to list all the factors of 320 because there's a lot. So I'm just going to find the one that we need and go from there. I believe it is 5 and 64. So now this becomes 4 times the square root of 64 times the square root of 5. So then the square root of 64 is plus or minus 8. So I'm going to put the plus or minus in front, and then we have 4 times 8 times the square root of 5. So then multiply this 4 times 8. So we have plus or minus 32 square root of 5. And there we go. So that's 4 square root of 320 simplified. All right, so for number 12, we have 2 times the cube root of 48. All right, I'm going to write out the factors of 48. And this time it changes because instead of square root, it is cube roots. So that changes the answers. All right, so here are all the factors of 48. So instead of picking the largest one that has a square root, we're focusing on the one that has a cube root. So the only number in this entire list that has a cube root is 8. So we're going to use this pair right here. Okay, so we have 2 times the cube root of 8 times the cube root of 6. And we did the cube root of 8 earlier, which we said was 2. So this is 2 times 2 times the cube root of 6. So 2 times 2 is 4. So this is 4 times the cube root of 6. And that's as simplified as this one gets. All right, so 13, I believe, is another cube root. So we have 3 times the cube root of 108. All right, so we need the factors of 108. And once again, 108 has a lot of factors. So I'm just going to write the one that we need. My calculator is dying, so it keeps turning off. All right. I'm just going to Google it. So hold on. I'm listening to songs as I record this, and it's like jamming to some Broadway music right now. So the largest factor of 108 that has a cube root is 27. So this is 4 and 27. So this becomes 3 times the cube root of 27 times the cube root of 4. So the cube root of 27 is 3. So we have 3 times the cube root of 4. And then 3 times 3 is 9. So we have 3 times the cube root of 4. And that is the final answer for that one. All right, so moving on to 14. And yes, I realize there are a lot of examples in this, but it's necessary because there are a lot of different types of problems. So we have the cube root of negative 250. All right, so we're going to focus on just the positive 250 and find the largest factor of 250 that has a cube root. And in this case, it's 2 and 125. So we have the cube root of, and we're actually going to put the negative with the 125. So we have negative 125 times the cube root of 2. And we did this problem earlier in the notes. The cube root of a negative 125 is negative 5. And then this doesn't change. So we have negative 5 cube root of 2. And that's our final answer for number 14. All right, so for 15, I believe it switches to fourth roots, which means we need the pair of factors of 162 where one of them has a fourth root. Okay, so let me get the factors of 162. All right, so we have 1 and 162, 2 and 81, 3 and 54, 6 and 27, and 9 and 18. Okay. So out of all of this list of numbers, I know not a lot of you have the fourths memorized, but the only one in this list that has a fourth root is 81. So we're going to use 2 and 81. So it becomes 3 times the fourth root of 81 times the fourth root of 2. So because we have an even index, our answer is going to have a positive and negative answer. So we have positive negative 3 times, then the fourth root of 81 is 3. We have times 3, times fourth root of 2. And then just multiply the 3 times 3. So we have plus or minus 9 fourth root of 2. And there we go. It's our final answer for that one. All right, so up until now, all of our problems have involved just numbers and the roots of numbers. Now we're going to add variables and exponents into it. So here is a little cheat to remember. So if you're finding the square roots, the exponent with your variable has to be in a multiple of 2. Cube roots, the exponents must be multiples of 3. And fourth roots must be multiples of 4. Right, so that's going to be our basis, is putting the exponents into groups with multiples of 2, 3, and 4. So we have the square root of 32, x to the 4th, y to the 9th. So we're going to start with 32. So the factors of 32, where one of them has a square root, and the largest is 2 and 16. So we're going to make this 16 times 2, and we're going to leave all of this under one square root sign. So we have x to the 4th power. So because our index is 2, because it's the square root, our exponent should be multiples of 2. So 4 is already a multiple of 2, so we're going to leave that as x to the 4th. But 9 is not a multiple of 2, so we're going to break this apart so that we have one y that has an exponent that's a multiple of 2, and then the leftover. So the closest number to 9 that is a multiple of 2 is 8. So we're going to make this y to the 8th times, and then 9 minus 8 is 1. So y to the 1st power. And now we're just going to work our way left to right and simplify this. So the square root of 16 is 4. So 4 is the what's left under there. So we're done with the 16. We'll deal with the 2 in a minute. And then when you get to the variables, what you do is you take the exponent and divide it by the index. So x to the 4th, so you do 4 divided by 2, which is 2, so it's x squared out here. And then you take the 8 and divide by 2, so it's y to the 4th. And then anything that didn't divide or have a square root, so in this case 1 doesn't divide by 2 evenly, so that's why that y is going to stay there. So the 2 is what's left of the number, so the 2 stays under the radical sign, and this y to the 1st stays under the radical sign. And then that is our final answer, simplified. So moving on to 17, we have the square root of 324 a cubed b to the 7th. All right, so I'm not going to list the factors of 324, but 324 has a perfect square root, and we'll talk about that when we get there. So we're going to focus on the variables for now. So we have 324, and remember, if there's not a number given, it's 2 for the index. So the closest multiple of 3 is 2, so we have a squared times a to the 1st. And then the closest multiple of 2 to 7 is 6. So we have times b to the 6th times b to the 1st. And now we have everything broken down to where we can simplify this the rest. So the square root of 324 is 18. So we have 18. And then 2 divided by 2 is 1. So you have a to the 1st power out here. This a is not moving. And then 6 divided by 2 is 3. So we have b to the 3rd power. And then that b is going to stay. So the only things left are the a and b to the 1st power. So we have ab under the radical sign. And that's our final answer for that one. All right, so for number 18, we have the cube root of 216 m cubed n to the 6th power. This one is really nice because 216 has a perfect cube root. The Cubed here is already in a power of 3. 6 is already in a power of 3. Okay, because now that this is the third power, our exponents need to be a multiple of 3. So all we're going to do is we're going to take the cube root of 216, which is 6, and then the same thing works here. So 3 divided by 3 is 1, so we have m to the first power. Then 6 divided by 3 is 2, so this is n squared. And voila, that's the answer for this problem. All right. So for 19, we have the cube root of negative 64 x to the 10th power, y to the 11th power. 64 is also a perfect cube, so we'll talk more about that when we get to the simplifying this. So we're going to leave it as negative 64. Now, we need to make the exponents into multiples of 3. So the closest multiple of 3 to 10 is 9. So we're going to make this x to the 9th power times x to the first. And then the closest multiple of 3 to 11, but it has to be less than 11, is also 9. So this becomes y to the 9th. But now 11 minus 9 is 2, so we have y squared for the other one. And now we're going to take the cube roots. So the cube root of negative 64, which we've done earlier in the notes, is negative 4. And then 9 divided by 3 is 3. So we have x cubed. X to the first power, or the leftover, is going to stay. 9 divided by 3 again is y is 3, so we have y cubed. And then 2 divided by 3 doesn't divide evenly, so it's going to stay. So the things that are left in the radical sign are x to the first power and y squared. And that is our final answer. All right. Moving on to 20. All right, so now we're taking the fourth roots of numbers. So we have the fourth root of w to the 4th power, v to the 12th power. So 4, anytime you have a 4 as an index, your exponents need to be multiples of 4. So in this case, 4 and 12 are both multiples of 4. So you're going to take the exponent and divide by the index. So 4 divided by 4 is 1. So we have w to the first power. And then 12 divided by 4 is 3. So we have v cubed. And then that is the final answer for this one. There's nothing left under the radical sign. There's no number to deal with. It's just this answer. All right, so for 21, we have the fourth root of 48 m to the 8th power n cubed. So once again, we need the factors of 48. At this point in the year, we should know the factors of 48 better than anything because we've used them so much. So now we're looking for the one number that has a fourth root in this list, and that is 16. So we're going to use 3 and 16. So we have the fourth root of 16 times 3. And then our exponents need to be in multiples of 4. So 8 is already in a multiple of 4. So we're good to leave that as m to the 8th. Now n cubed, there isn't a number less than 3 that is a multiple of 4. So it's actually going to stay n cubed. And there we go. So now we're going to do our fourth root. So the fourth root of 16 is 2. The 3 is going to stay. Then 8 divided by 4 is 2. So we have m squared. And then we can't divide 3 evenly by 4. So that's going to remain underneath the radical sign. So we have the fourth root of 3n cubed. And this is our final answer for this problem. All right, and then moving on to 22. So we have the square root of x plus 12 squared. And we've already dealt with this situation many, many times this year, but as just a refresher, the square root of a squared, they cancel each other. So the square root and the squared go away. So the only thing left for this answer is x plus 12. And that's it for that one. And our last example, we have the fourth root of y plus 3 to the 8th power. All right, so 8 is a multiple of 4. So just like with the previous problems, you're going to take the exponent and divide it by the index. So 8 divided by 4 is 2. So this is y plus 3 squared. And this is the final answer. Oops. This is the final answer for this problem. All right. I know that these were long notes and there are lots of examples, but if you got it this far, good job. All right. That's the end of these notes. Have a good day.